I wanted to start with, today we're going to start with Unity, and we're going to do a bit of coding, an introduction to Unity's pipeline and everything. Um, I would like to stress out that I'm not going to write completely 100% clean code. So some of the code which I'm going to write is going to be some of them is production ready or semi-production ready, and some of them are not. Okay, just to be clear on this point. And for the reason, the main reason is for me or for me taking this route is that I need to deliver a point, or I need to make some stuff clear. If I start writing very convoluted code, you probably, I mean, because it's the beginning and everything, probably you're just gonna hate the whole process, even though it is actually quite simple. I mean, it's quite simple, not because I'm not saying that you guys are not smart enough or anything, but it's just because graphic programming or game development usually involves interesting patterns, interesting decisions, depending on the game. So if you are creating a game in Unity, if you're creating multiple games in there, you will end up with almost, I would say, 75% of the code is going to be different. There's 25% which is going to be reusable. I will show you one piece, for example, which is going to be, let's say, the controller, how you can make a reusable controller that you can reuse throughout all your games. But the rest, the idea here is that we need to learn, we need to understand how the computer works, how computer crunches through 3D graphics, and how we make real-time applications. Hopefully one day, if HoloLens becomes, for example, HoloLens from Microsoft, if it becomes more available, you guys have to work in Unity in order to create applications. I've worked with HoloLens personally. We have created applications for it, and it was through Unity. Knowing C# very well, knowing how 3D graphics work, you probably can do amazing stuff for phone, for any other devices for that matter, whether it's mobile tablets and whatever goggles you could wear. All right, I'm gonna start sharing my screen. So since we have hit the time, share screen, and please give me this this screen. Okay. Okay, connecting. Give it a second. I don't know if you guys can see my screen yet. I'm waiting for it because it's just connecting all the time. Anything yet? No? Hello? Guys, are you there? All right, guys, can you hear me right now? You see my screen? Okay. If anybody listened to me in the past, like 2 or 3 minutes when I was giving an intro? Okay, good. Okay, because for some reason Skype just, went nuts and I couldn't like share my screen for some reason. All right. Okay. Okay, so I'm gonna start a new project. I'm gonna use 3D, and I'm going to uh, call this the star underscore DL underscore online. Okay, and this is gonna be our progress record of our application or our game. All right. Now, I'm actually not gonna make a I'm not gonna make some sort of an FPS or anything. For the sole reason is that I'm one of those people who get motion sickness out of first persons. And for those who are wondering how you can get something like this, for those people who, for example, suffering from VR problems when they wear VR goggles and then they, for example, start to get motion sickness, they would like to throw up. You have there is this part in our body, like our brain, just thinks when it sees something real, when it sees something like, for example, our 3D. If you're playing FPS or something like that, your brain starts to get convinced that this is real. However, there are things which do not behave nicely in the 3D world. So, for example, if you are wearing, for example, VR, and you are like looking around and everything, and if there is a lag in how you're turning around, this is not what you got used to. Your brain got used to, like, when I turn around, everything is just where it should be, right? Everything behaves as it should be. So if this doesn't happen as it should be, like if your brain perceives it's like, no, this is not how things work, it will tend to think that you are being poisoned, hence you are getting hallucinations, right? And when it says, hey, I'm poisoned, the only thing which receives poison is through your mouth. So probably you eaten something or you drink something, and you get, it's saying things, okay, you have eaten this or drank this in order for you to get this kind of illusions. So it says whatever is inside your stomach, just get it out. Hence throwing up action. Okay, so this is why people usually tend to have motion sickness and nausea when they are actually using VR goggles. Or at least this is mostly like what people think. So I'm gonna have a space shooter top down. It's gonna be still in 3D, but we're gonna look at it from top down. Okay, and it's gonna be I think as I already said, partially is gonna be like in a production code. Another part is going to be like, let me drive the point, and then you can refactor that code to make it a little bit more, not a little bit more better, actually. Okay, so in Unity you have, before I actually carry on, how many of you have tried Unity, created a game in Unity, published something, just out of curiosity? How many of you? It's just statistically speaking, nothing embarrassing. Just hit me with the thing. Tried it yesterday. If that counts. Irma, were you on the classes yesterday, or probably somebody else? Because there are multiple Irmas, I think, in this world, definitely. Okay. Jan installed it and opened it once. Great. So people just open it and say, does it work? It works. X, right? That's mostly what happens. All right. So in any game engine, game engines usually are composed of several components. So you have the graphics part, you have audio, you have physics, you have scene management, you have hardware interfaces with controllers. You have so many other things. Actually, I cannot even count them right now on top of my head. But Unity is a game engine, which encompasses all of this. And it's a generic game engine where you can actually create basically whatever you want. You can create a 3D graphics application, or you can create a 3D game or a 2D game. I haven't seen 2D graphics application honestly made in Unity. I think it's going to be like counterintuitive. At least this is me personally. Probably I'm wrong. So so you usually have the game view, like the output, and you have the scene view where you're actually playing with stuff. Scene view, if you hold the Alt key and left mouse button click, you can rotate, right? And right mouse button to dolly in and out. So we hold the Alt key, right mouse button, and dolly in and out. Hold the Alt key again and middle mouse button, and then you can pan. So technically speaking, you can go around anywhere in the world with these 3 buttons while holding the Alt key. I'm keeping holding the Alt key, and I'm just simply like, rotating. And you can see here this icon is changing, right? So let me add a cube here just to have it as a frame of reference. Okay, so right click, create a 3D object and a cube. You have several of them, but we are actually just interested right now in the cubes. Maybe I'll add a sphere, and I'll just simply move it. Now, in Unity, you have X, Y, and Z, and you have the Y is pointing up, okay? Z is for forward, so positive Z is forward, negative Z is back, positive X is right, negative X is left. Of course, positive Y is up and negative Y is down. So right now you know the coordinate systems. There are other 3D graphics packages, like for example 3D Max, where you have the Z is pointing up and Y and X are on the floor. I think this is called the left-handed coordinate system, as far as I remember. Here is the right-handed coordinate system. Okay, as far as I remember. I hope that I'm not making a mistake here. Anybody have done 3D modeling before in this class? Anybody touched 3D Max, Maya, or Blender? Have anybody tried any of this? Out of curiosity, I mean. Seriously, no one. Aha, okay, Cinema 4D, yeah, I forgot Cinema 4D. Okay. This is statistically weird, I have to say. A little bit of printer. Oh yeah, Rhinoceros. Yeah. This is like this is an old, actually. It's not an old, actually. It's a sculpting application, so I remember. 10 years ago. Oh wow, dude. Okay, I thought that you guys are young. Oh. Okay. All right. Okay. So, I mean, this is going to be familiar ground for you guys then. I suppose that those 50 people is the combination of the two and the second and third year. I tried to make Cydian for PS 2010. Cool. Have you succeeded? I mean, in your trial. Well, if you have any screenshots, feel free to shoot. I would like to see it. Okay. Honestly, I was doing 3D modeling for 10 years professionally, and I have so many unfinished projects, so it's fine. But if I'm doing something for production, then I have to, you have to finish it. But so I have a lot of personal projects that probably just got stuck or I lost the interest into. But this is a normal thing when you are beginning, I guess. Yeah, good point. All right. So since we have people who are familiar with 3D graphics, I think this is going to be a breeze for you then. So Unity have scenes, which we the normal people call sometimes levels. Okay. So you have scenes in there. So I can hit Control S and I save my scene. Scenes are here in the scenes folder. They created it for us. They're organizing the stuff. So I can right click and create another folder, and I just simply name it whatever I want, and it actually maps to my folder hierarchy on my hard drive. Okay, so that's the important thing. I probably missed to mention it for the other people. Now, there are a couple of things which I need to hammer on, because for those who are not familiar with 3D graphics in general, you have lights and you have 3D objects which have positions in the world, okay? And there are many more, but I will stress out, and cameras, okay? And cameras. Now, there are three things which you have to understand. The first thing is, in order for you to see an object in a scene, you need to give it a material, okay? Now, a material is a fancy word for a shader behavior. Now, what a shader is a small program that gets executed exclusively on your GPU in order to tell how the light will behave when it bounces off a certain object, okay? Will it be rough? Will it be smooth? Will it be a mirror? This is all described in that program, which is called the shader. Shaders as well, sometimes they are encoded into your, I mean, I wouldn't say encoded in the hardware maybe, but let's say that the hardware actually has a huge contribution into the shaders part. So for example, I don't know how old were you, but if you remember video cards that had shaders support, you have these on these boxes, you have a video card written supporting shader language 1.0 or 2.0, or right now I think 5.0 or 6.0 right now has been released, right? And all of these stuff is like you are calling certain functions that are built in or embedded into your video card that you can call, so it will work, so you don't have to do light calculations and it would go super fast, okay? Usually you try to make everything in the hardware so it goes much faster, because the hardware is faster than software eventually, okay? Now, in real-time 3D graphics, you have three types of lights you're going to interact with, okay? The rest, you cannot have it in real time because they are super slow for calculations, okay? You cannot have 60 frames per second, or it's super difficult to have 60 frames per second for a lighting, for other than those three lights, which are directional, which is simulating the sunlight, the spotlight, which is practically what it says, spotlight like in theaters, and you have the point light, which simulates a light bulb, and then you have area light, which says baked only. That means that you can bake the light information into a texture on an object, and I'll explain this in a second. But let's carry on with the directional light first, because it confuses a lot of beginners here. Now, directional light, if you look at the matrix, the matrix behind the directional light, you will see that the light is shining to you from a fourth dimension, because we are using 4x4 matrices. And I already have posted this in the materials. I hope that you watched them. The directional light specifically shines from the fourth dimension. That's why if you open any tutorial in any 3D modeling program, when they mention directional light, they say, imagine it as light is coming from infinitely far away, emitting from an infinitely large plane. Okay, this is what happens when you have something coming at you from the fourth dimension. Just things get parallel, right? And all of the rays there are parallel, by the way. So that's important point to mention here. What you only care about, what you're gonna get the feel or the effect for the light is when you rotate it only. Okay, so if I grab the light and I try to rotate it, it will start affecting my scene. Now, Unity was kind enough that they actually simulated the whole thing. They put a nice spot here for the sun, so you can see it. They actually changed the haze of the scene. RTX on. RTX. No, I don't have RTX on my machine. Just to be clear here. So this is actually just Unity stuff, I think. I don't know if you're just talking about the sun stuff. This is Unity stuff. So if not, then please be more detailed or verbose. Okay, so this is like what the sunlight is for. If you are actually working with OpenGL, what we have worked with in the past, like several years ago, when I was teaching OpenGL back then, people had to create their directional lights, and if you move them around, it doesn't get affected because anyway, it's coming to you from the fourth dimension. Your three-dimensional positions are, practically speaking, meaningless. What means for you only is just the rotation. Okay, you have algorithms, by the way, for simulating the sunrise and sunset. For now, for Unity, because of course they just give it to you, out of the box, and they were really nice to implement it for you. You have always sunset. It never sunrises. You never get the sunrise. So this is a color which you get on a sunset, and again, this is a color which you get on a sunset. If you are talking about the sunrise, we usually have this dark blue to white haze, and then when the sun sets, we get what, like orange and reds, right? Right now we have just only the orange and reds, because anyway, it's kind of difficult to determine which is where and stuff like that. It's a long story when it comes to simulating sunset and sunrise. But in any case, you have right now this directional light. So do not, waste your time positioning it because it doesn't matter. I usually position it somewhere high up where I don't see it. I just simply adjust the rotation and we are good to go. Okay, this is how my game window output sees it. If you have, let's say, if you have multi-monitor setup, please use it. So for example, put Unity on one monitor and then put your Visual Studio on another monitor, or you put Unity and the game window in a separate monitor, and so on and so forth, because these guys are detachable. If you have 3 monitors set up, then it's even perfect because you can just simply put the game window on one screen, put the Unity on one screen, and then put Visual Studio on another screen, and you have right now a blazing fast workflow. So if you are one of those people who have multi-monitor setup, you can utilize it in that way. Okay, so this is about light, in directional light specifically. You can, of course, change the color of the light. You can just, make it red. And as you can see here, my objects became red. Let me just undo that and undo. Okay, so that's one way. I don't want to mess this up because I will not. I think there's a reset. Yeah, there's a reset right there, so you can reset the light values. Now, you have point light. Point light is the same as the light bulb, as I said. So if you have a room and you have multiple lights, oh boy, not you. Hang on. And then we go here. And then we go there. So if you have a room with multiple light sources, you can just simply have multiple of these things, and it shows you here the area of the effect. You have the range, so this is the range which you want to. You have the color. You have the intensity, how strong that light is, okay, which you can play with it. Indirect multiplier is like the indirect lighting, but I think this is as well. Real-time indirect bounce shadowing is not supported for spot and point lights. Okay, so for those who don't know what I'm talking about, let me grab you something that can indirect lighting. So just to show you what I'm talking about, if you look at if you shine light in your room or wherever, some parts of your room or some parts of, this scene, let's say, it doesn't get the light directly. That's because the light just bounces off everywhere and just illuminates that certain area. This is called indirect lighting, and it is it's actually complicated in graphics to calculate, and it's quite computationally intensive. So, for example, this area, let's say here, it's not reached directly by the light, yet it's illuminated. This is how the light bounces around you and in your room, in your scene. So, so because this is quite difficult to achieve in real time, or you need a super powerful computer to do that in real time, you have baking, where you can bake that stuff. Okay. Now, this is for the point light. We have spotlight, which is like the like in theaters. I think you already might have guessed it. So the position of the light and everything is actually getting affected as well. And an area light is just for baking, which says how your lights are going to be like emitted. And I have to initiate the baking process, which is going to take some time. And you probably will not use it, so I'm not going to actually delve too deep into that because I have to wait for the thing until it bakes. So I'm going to use directional light now. I'm going to reset the parameters to directional. Okay, it doesn't matter. I think it's good. So I'm going to push it upstairs. Okay. Now everything in Unity is a game object, more or less. And the simplest game object is that you just simply right-click and create empty. Now the empty game object is a transform, so it's just a simple point in space, you could say, a position in space, not a point, because point is different. So it's a position in space. You can rename it here, hit F2, or right-click and rename, or you can name it just from here. You just simply say, this is a random point if you want to, but this is up to you how you would like to name your shit. Now, I'm just gonna, yeah, so this is one, and you can still add components on top of that. Now, if you look at your cube is a transform component, which is a position in space. You can add to it something which is called a mesh filter, which contains the mesh itself, i.e. the description of the vertices in order for them to be drawn onto the scene, the polygons themselves, okay? And then you have the other component, which is the mesh renderer. You need a material in order to see things, in order to see how the object will behave under the lighting condition, as I said. So if I uncheck this, some time ago, Unity usually printed this as an error, and it gives you a kind of crazy purple color. It's an obnoxious, actually, color. Hang on a second. Purple or transparency, even. Graphics. There was a shade of purple used in transparency in 3D graphics. It is so obnoxious. Transparency graphics, transparency purple. Color value. Alrighty, so I think it's one of those. I just cannot remember which one was it. It was super. It actually has been chosen because historically people will. It's this one. Surprisingly enough, it's like the text, not this, but this. So it has been used. It has been used for a reason because of the. Funny thing here is because it's the people, they found that it's super annoying for people to look at, so they just simply said, we're going to use this color for transparency because it's impossible, no one ever going to use this. So they just simply used that color, and it was been used in Unity a long time ago. Right now, apparently they stopped using it for some reason. Right now, if it doesn't have a material, it just doesn't exist. So I have to have, or this is the mesh renderer. Hang on, none. There we go. So that's the color which I was talking about. Super obnoxious. Nobody uses it, and it's being used for transparency for a long while. So right now I'm just going to use a material which is, let's say, is going to be default diffuse. There are many of them, by the way, many shaders. You can write your own shaders, but this is super advanced. We're not talking about this. We're not going to talk about this for sure. Your lights can cast shadows. So if somebody is under here, and we can see if do I have shadows? Probably I need to enable some stuff here. This is receive shadows. I need to say it casts shadows, probably. Somewhere in the settings, I think. But this is going to be another, probably going to address it in another video because shadows are a quite interesting subject. All right. Now, you can create your own materials, by the way. So file, new folder, I'm going to call this materials. I'm going to need it anyway, materials. And this is going to be for the player, I think. So player. And then I'm going to actually create a new material. I'm going to call this the body. Because we're going to have a starship and warp speed and such. Any sci-fi fans in the crowd? Magenta? I don't think so. Sorry, I just read the chat right now. Magenta. No, magenta is actually being used. People use it. I think it's a shade of magenta then, probably. So this is what magenta is, and magenta is way less obnoxious than the one which I've seen. Okay, so if this is the body, I'm going to make it opaque, which is not transparent. And transparency, by the way, is it could hit on your performance, so you be careful about that. Because it forces the ordering of rendering to be forward and backward and stuff like that. It's our computers can crunch it, but if you have too many of these transparencies, you can run into performance issues. So be careful about the transparency. Be conscious how you integrate that shit in your game. So I'm just going to put this body. So anyway, there are several ways of integrating a material. So you can grab a material and just drag it over here like this, or you can drag it over here like this. Okay, so you have those two options for you. Or you can click, and then you choose the body from here. Okay, so you have that, X, and we're good to go. Now I'm going to grab the sphere, delete it, take this random point and delete it. And I'll call this is the body of the ship, or this is the player ship, or this is the starship. Okay. Now, I'm gonna start doing some scene manipulations here, so you can get used to the idea of creating a game object of some sort. So I'm gonna put this into 0, 0, 0, and this guy as well, the starship. I'm gonna put it as well in 0, 0, 0. And this is going to be my wings, so I'm going to call this wings. And oh, by the way, if you lost the focus on a game object, let's say like this, and you try to work with it, but you are trying to focus on it, but somebody else is grabbing the focus, you can focus on a game object by just simply selecting it and hit the F key like this. So right now you're orbiting around it. Okay, so I'll grab this little guy, reset it, and F key, and we're in focus. Now I'm going to scale this little guy to be, let's see, so 0.5 in Z, maybe 0.25 in Z. I'm going to scale it in Y by 1, 0.25, I think. And in X, I think I'm going to make it 20. Oh boy. 10, or even less, 7. 5. Units in Unity is in meters. Just to be careful, just to be clear. Maybe even 4. Okay, now let me position my camera. Oh, the camera, very important. I forgot about this one. Cameras are showing you how your scene is looking like or distorted. So we have many projections in computer graphics. The most useful projection for us in 3D real-time graphics is there are two. You have orthographic, which is similar to the old games like the old Diablo 1, Age of Empires, the early ones, 1 and 2, the old, the what was this? StarCraft. And these games are actually having these orthographics projections. Basically, their cameras are called isometric. You get these isometric views, right? The point of this camera, this perspective camera, is to get the things bigger when it gets closer and smaller when it gets farther. Okay, that's what the perspective projection means. If you would like to change it, you can change it from here, and you can make this orthographic. Now, once you have orthographic, you lose all the depth. There's no depth, okay? You can put objects behind other objects, but no matter how far or close the object is, it is still gonna be the same. Okay, it doesn't get smaller. Now it depends on what you would like to do. Also, important thing to say here, and I rotated the camera on like this way is intentionally because I wanted to show you that in the orthographic world, everything is in parallel. So all these lines are parallel. Okay, so no depth and everything is in parallel. Like all the lines are parallel to each other. I'm going to return back to perspective where things start to have a vanishing point, by the way. So all the scene leads to a single point, which is called the vanishing point. If we have photographers among us, in those 50 people, I hope that there are photographers or photographer hobbyists. You already probably know about the vanishing points and perspectives. And you can have multiple vanishing points in your photographs. In graphics here, I think we have only maybe one or something like that. I mean, it depends on how you set up your camera, but in any way. With perspective projection, you can have a vanishing point. Now, let me put this rotation into something that is useful. So I'm going to position my camera up, and I'm going to rotate it in X by 90 degrees. So right now, it's a top-down camera, okay? So there we go. We have a top-down camera. Now, probably I could even position this in 0, 0, 0 and just simply push it up. Okay. And grab my starship and start doing some scene hierarchy organization. Now, the wings belong to my starship, so I'm going to grab the wings and put it under the starship. So right now we have a hierarchy. And I will grab the starship. Actually, I will grab this, and I need a tail because I need to know what is forward, what is back. So I'm just going to Control D to duplicate, and I'll just simply say this is the tail section. And I'm going to give it the most obnoxious colors so I can see them in the scene. And because the screen sharing is not, you know, fully HD, blah, 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 I'm just going to make this as obnoxious colors as possible. So let's say that this length is fine. I'm just going to push it in the back, maybe a little bit less. So we have some sort of a tail section. And I can go even with it a little bit more, and I'm just going to squeeze that in, squeeze that out, you know, push that in. So we have some sort of a teeny tiny tail, and probably one more. Oh, okay. Not scale in negative. Okay, so we have scale, and then things go to negative. Do not do that. You could invert the normals. Normals are used to say if the face is actually pointing outwards or inwards, so be careful about that. Otherwise, you will not. Sometimes you will not end up with the correct scale or the correct. How can I say? Polygons could disappear in front of you. You can see them in the scenes maybe because Unity is kind enough to show you both sides of the polygons. But for example, in some games or in some games, depending on the platform you are targeting, it might not actually detect it, and you will lose the whole cube, okay, or the whole object. So be careful not to scale in negative. Probably I had to mention this for the other classes. I really forgot about this. Okay, so we have some sort of a tail, introducing some aerodynamic stuff. Now I'm gonna add couple materials here so I can see my stuff, and this is going to be okay. So these are the wings, and right click new material, and this is going to be so wings. We have tail, and I will keep it that way for now. Yeah, I will just keep it these three. Maybe I'll add one more. So the wings, I'll make them more like green. So just they're super green. So right now I can drag it like this as well. So this is another trick. Tail, I could make it blue. So right now, body, tail, blue. And I'll leave these guys as this. So I'm actually going to grab this. This is the tail section, which is fine. This is like tail wings. and this is like the tail tip, I think, of some sort. I'm not good with avionics terminologies, but it will work fine for me, I think. Here, okay, so everything is grouped, and I grouped them for a reason. So if I move this as a whole. I don't have to think about moving these stuff one by one. Okay, so I move this thing as a whole. Okay, now that we have that, we can actually start working on something. Now, if you can see, when making games usually, or making any 3D graphics application, you don't care about the details because you need to care about the application. You don't think about how this character. I mean, one of the meetings you could have is like how this character looked like, this part of the R&D, and this nice first game or the first meeting's romantics is like, you know, it's fun and everything. But when you program, when you get the task and you start programming, you will not actually work on the character or anything. You will just simply put a bunch of cubes like I did, and then you start programming. And then later on, the artists and the modelers and the animators, when they are actually done with their stuff, they just simply say, hey, go ahead, replace this cube with that character. And right now we have something, okay? So, and because I'm not gonna do 3D modeling here, I just simply said, okay, I'm just gonna put a bunch of cubes and let's work, okay? Now, this is the materials, the players, we have the scenes. Now I'm gonna rename the scenes to my main game and reload, okay? Because this is my main game for now. You can create many scenes, like many levels, and you can switch between them, right? You can load that scene or load the other scene and so on and so forth, okay? Now let's move on to programming a bit. So I'm going to go ahead and create a new folder, and I'm going to call this scripts. And right here, I'm just going to right-click and create a new C# script. Now, this is the part which I'm going to write a little bit clean code, a little bit, okay? If you would like to control that shit, you need to accept the keyboard inputs, okay? Now, accepting the keyboard input is easy. You just need to know how to put it. Now, there are many ways of doing this. So, for example, you could say if the key has been pressed, or if the up key has been pressed, you do that logic. If the down key has been pressed, you do the other logic, and so on and so forth. Which we're going to do, but we're going to abstract it in a certain way, so we're going to have a much clearer code. But first, we're going to look at the Unity script execution order. And before that, let me just write this. So we have this input management, which is responsible for handling the input of the user, and it doesn't care about the game. So this script is going to be completely unaware of the game. And before I forget, for those who installed C# or Visual Studio separately than Unity or something like that, be sure that you run the Visual Studio installer. So let me grab this Visual Studio installer. And anytime now. So you say modify, and you enable game development with Unity and these things. So you can enable that one. You will have this open somewhere down there. Just if you have Unity already installed, do not check this. Make sure that the Visual Studio tools for Unity is checked, and C# and Visual Basic is going to be checked anyway. But Visual Studio Unity tools, you need to check those two anyway. Unity, be careful. Unity has its own compiler, so it understands .NET Framework and everything. So it grabs the old .NET Framework, I think 4.5 or something, and then it translates this into its own through its own IL to CPP. And then it's actually CPP is like C++, and then it just intermediate language to C++, and then it just simply executes the whole thing. Okay, so so be careful. Do not use, for example, the latest greatest feature from Microsoft.NET Core, let's say, because you might end up having errors in Unity, and your game will crash. Your Visual Studio doesn't say anything, but Unity cannot compile it because it doesn't understand that new feature, and they have to code that into their own compiler. Okay. they do a lot of optimizations in C# in order for this to run super fast, so you can do games and real-time graphics. Okay, I've been running for an hour right now, so I will actually give you a break 10 minutes, and then we'll get back again. We will see, hang on, so right-click, open C# project. All right, okay, hang on, let's give it some time. I'll grab it once it loads. So there we go. Here is our script in a minute. So there we go. This is our script, which we're going to discuss what is a start, what is update, how all these things work after the break. Okay, so you go ahead, have your break, and we'll see each other in 10 minutes. All right. 10 minutes have passed. Everybody is at their seats. Is anybody around still? Okay. All right. It's actually quite interesting when they have like 5 or 6 people speaking for the 50 in the room. You know, it's kind of cool. Anyway, and everybody's like lazy. Oh, I'm not gonna type those 3 letters, so just let it be. Anyway, so I did right-click and open a project in the input management, if you remember. Now, I'm just gonna try to compress a couple of things here. First, I'll put this aside. Now, in Unity, we said that we have several components, like we can add components onto the actual any game object we would like to do. So we can right-click and create an empty game object for now, because I would like to separate the input management from the player himself. Imagine that you would like to have, like, what was the name of the game? Frozen Synapse, I think. But let me see. Just give me a second here. Let me write this input management. Okay. So this is like going to be my game object here, which is its responsibility just to hold a script, and that's it. And if you would like to register some stuff in the Unity cycle, like the update every frame, do something, you really need to include that script inside a game object, and it has to live in the scene. It has to be enabled. Okay. So I will hit Control S here, and I can add a component. I can add an input management script right there, because it's going to be a component. And if I click and drag as well, I can do the same, pretty much the same thing. So add a component and choose the input management, or just click and drag the script, and you're going to have it right there. Now, of course, nothing is interesting happening here. Let me show you something here. Unity execution order. Order of executions for functions within Unity is very, very important to know. Whitelist. Okay, so if you go to the Unity's documentation, you will see that there are certain events that are taking place that Unity is actually registering. If you look at the code, so the code, when I created that script, it has the start is called before the first frame update. Update is called once per frame. Okay, these stuff are reserved in Unity. Okay, you don't name a method start, void start. You will confuse it, and it will just simply, like, you know, I don't know how it will behave. Also, I never tried to play with the idea, because I never needed to, and there's no need to do that. But you have several methods that Unity calls automatically as a game engine. Okay. Now, one of them is, you have the awake. You have a lot of them, actually, but you have the awake. This is like the first ever method it's going to be called on a game object. Now, probably some of you might think, okay, but what happens if I have multiple scripts in my game attached to a single game object, or multiple game objects for that matter, and each one of them has the awake method is written in their some code? Which one is going to be called first? Unity is going to arrange that order for you. You never touch it. However, if you run into a problem like I did, for instance, several times in production, what you do usually is you go ahead into the project settings, I think, and you have the script execution order. And right here, you start, for example, saying, okay, that input management is going to run first at that time. I don't know, whatever. Character controller is going to run second at that time, and so on and so forth. So you can ensure that some certain variables which you rely on in other components already have been initialized. So this tells Unity, hey, please make sure that this starts first, then this second, then the third, and so on and so forth. Okay? You never touch this unless you have a problem. Okay? If you don't have a problem, you don't touch it, because you don't have a problem. But if you have a problem, right now it's time for you to play with this. Okay? Now, Unity already have like inserted how the execution order of certain things are going to be, and you don't touch that. But if you needed to touch it because of a problem you had, then go ahead by all means. But my advice is you only touch that part when you really have a problem. Other than that, just don't touch anything. Revert. Okay. Now, just to be sure, where is my this? So the first thing is called is awake, then on enable, then reset, then start, which is this little guy. If you need awake, you just simply say void awake, and that's it. It's private anyway, so you have it that way. Okay. And I think because of Unity tools already has been integrated, so that's why I have these IntelliSense part reset. You see, which is reset. Okay, you have on collision, stay, enter, exit, and so on and so forth. These functions are already built into the pipeline, which we're going to see. Now, let me close this. So fixed update is being called state machine update. I think you cannot touch that. On-state machine, enter and exit. This is for people who have state machines in their game. Unity has already a state machine stuff in there, so for you to play. Okay. Physics, you don't touch it. Usually you only touch just on the animator IK. IK is the inverse kinematics, which is used for character control. So if you would like to control a character with limbs and stuff, if you like to control characters with limbs, like if you have a humanoid is walking because of kinematics. You have and the joint system and the joint looks. It's actually a quite big topic. We can waste like 2 hours on the topic itself. It's quite big. But let's say that this is the part where if you have humanoids, if you have actually animals, characters, whatever you have that have joints in them, this is where the part is being handled here. If you would like to override that, you can override it here. On trigger, it's like if you have played games where you have automatically opening doors. So if you walk into an area and then the door opens, you already have a trigger box. We're going to see that. And it's called on trigger enter. So when you enter a trigger or you stay inside a trigger area, it will just simply trigger a certain event. On collision, if you collided with something, on collision enter or collision actually exit and these things. Yield, wait for fixed update. This is going to be another topic. It's about how you handle physics in real time with a certain delays. If you would like to have something that every certain amount of seconds something happens, this is where you handle that. After all that, by the way, your mouse input is being handled. So on mouse click or I don't know drag or whatever it is, you have it here. After the mouse input has been handled, you have the update, which is the part where the drawing happens or the part where things start to move in your scene, literally. Now, this is also very important. The mouse input is happening before the update, okay? Just keep that in mind. These stuff are not important for you probably because I haven't seen up until now a student who's making image effects. But if you are one of those people who are super adventurous and they would like to play with distortion, motion blur, and what was the name of it? Bloom and making these interesting visual effects with images, you have to play it right there. On draw gizmos, it is something which we're going to use probably. It's only within the editor, by the way. It's not in the game. On GUI, this is for the GUI part. And then we move on until we get the application, like when the game object gets destroyed. So if you say game object to destroy, so it will disappear from your scene, this is the last method which is going to be called. Now, for every cycle, every frame, let's say, your whole game goes through every game object, and every game object of yours, which has a script or multiple scripts on it, it just runs through this cycle. Okay, all these methods are being called one by one. If you handle them all, then the computer will just call them one by one. Now we never handle them all. You never will do that. I think you will do just one or two methods, and the rest is going to be handled by other stuff. So usually what you care mostly about is awake, start, and update. On collision enter, on collision exit, and these things we care about when we'd like to have interactions, but that's pretty much it. You don't do anything else. The rest is just, it depends on really what you right now do. So I'm going to minimize this. I'm going to go ahead with the input management. Now, now that we know there's something which is like, but now that we know we have a built-in methods in Unity, I'll create a void awake, and I'll just simply erase start. I can actually, I think in the previous lesson I've made this as I put this in the start, but it doesn't matter. Probably I'm gonna actually, it's private by the way. Do not make them public. You will just, Unity will not respond to you. Now, if you would like to add, if you would like to make people control the stuff which you have, so input management, you have the script right here. If you have noticed, you have properties in here, isn't it? These properties to appear. Now, if you'd like to have these properties in here, you're going to write these properties right there. And Unity serializes only fields. It doesn't see properties. So, for example, if I have, let's say, public float, speed, get, and set, Unity just doesn't see that. Because again, Unity has its own compiler, as I said. It just says, I would like to see only fields. So the difference between a property and a field, this is called a field. A property has a get and set. So if you go here, right now it's visible. Now the interesting part here is, sometimes from the software engineering perspective, you don't want somebody to manipulate that speed somewhere else from some other scripts, right, or from other classes. So we tend to put this as private. However, if we go private, once Unity compiles that shit, you get this thing disappearing. Now, if you would like to make this appearing again, you just have to mark it as a serialized field. And once you mark it that way, it gets there. Now, there are several headers that Unity actually provides. For example, you can have an actual header, and you can say, for example, this is like controls. Sorry, I have to put a string here. Controls, and once you do that, you get, you know, controls. Now, this has been added for you. Zoom. I cannot zoom. In the code, you mean? Like this? Good. Okay, because I thought that the UI, and I was like, I cannot increase my DPI live. But anyway, so if you put the header controls, for example, you will get this. You can add some help, like tooltip. And you can write in there, you say, the tooltip is going to be, this is the speed. Okay? And if you go here, after it gets compiled, if you highlight this, you see this is the speed. Now, this is a good thing if you have people who are designers who are not going to dig into the code. So you give them these helpers so they can understand what they are doing. If you are making a plugin for Unity and people will use it, you sell it, or in the Unity market, you need to add tooltips so people can understand what they are modifying. Okay. Another one interesting, which is, for example, range, which you're going to use. I'm actually showing the stuff which I'm going to use a lot, by the way. So range, for instance, has minimum and maximum. So I can say, so nobody breaks your game. You say that the minimum speed is 0, or actually the minimum speed is, let's say, 1. So your ship doesn't stay in place. And the maximum speed, let's say, is 20, because if you have higher speed, then probably it will break your game. Okay. So you don't want that to happen. Let's see. I think, was there anything else in the? Yeah, that's it. That's pretty much it. So right now your speed doesn't become like a number, but you can write the number and you can actually modify the actual slider, right? So the minimum is 1, the maximum is 20. Now you ensure that no one will actually, let's say, break your game. Okay. So this is very important. Properties that I'm going to use a lot, so right now you know what they are about. Okay. Hopefully I'm not too fast. Anyway, you're going to get that code in the materials, so no worries about there. You can have a look at it, you can play with it, you can do whatever you want. And now I'm going to carry on. Now I'm just demonstrating this with the speed. Now input management, if you look at the speed of the ship and the input management, they are not correlated. There's no relationship between the input management and the speed of the ship, because input is related to the user and their keyboards or their joysticks or touch screen or whatever, and the speed is related to the speed of the ship. So input management, logically speaking, doesn't have anything with the speed or the ship itself, because I could swap the chip with something else. I could make right now not a spaceship. I can make it a car on a lunar, you know, on a lunar surface, let's say. So I'm going to erase this. And in order for us to make a good input management, what we're going to do here is I need to make sure that the player or the designer, sorry, can modify the keyboard shortcuts, because I'm going to use keyboard right now. The rest of the class, at least for the rest of this game, I'm gonna use actually keyboard shortcut keys. Now there's a very important one before I carry on. So if you would like to handle inputs in Unity, you just simply say if input dot get key. You have get key down, which will detect only one press. You have get key, I don't know, up when you lift up the button, and get key, it just, as long as you're holding the key down, it will be there. Key code dot up arrow. And then I will just simply debug the log. I'm just going to say pressing up. Okay. So if I go over here, and it compiles. So if I hit the run, if I hold up, as you can see, it's keeping counting right there. See, I'm holding up arrow, it keeps counting. And right now you can actually add all the logic which you would like to do. So for example, if you would like to add the logic of, for how the ship is moving, where it should go, where it shouldn't go, and so on and so forth, you just simply add it here. So you can have here another 100 lines of code if you want to. It doesn't matter. It will just simply, in the update, if you press that key, all the thing will be executed, right? Now, because we would like to make this thing clean, and I would like to reuse that input management, I'm not going to handle it in that way, though. Now, of course, you can have if input.getKey and then key code dot down arrow. Okay, fine by me. Right now you can handle when people just pressing down arrow. So if somebody cancel, if somebody actually presses up or down or up and right at the same time, the ship will go in two directions at the same time, and so on and so forth. Now, in order for me to make this a little bit modifiable, I will actually enclose this into a property or in a field. So I'm going to have this private key code forward. Okay? Now, I'm describing this as forward because the ship will go forward when I press that key. And right now, what I can do is just simply grab this and push this right into here. Okay? And if somebody has pressed the key code of back or backwards, whatever you'd like to call it, we're going to handle it right here. Let me back for now. Forward, back. Now, of course, because they are privates, they are not going to be visible in Unity, so I have to make them a serialized field. And do not forget to disable your game, because if you make modifications to a script while the game is running, it will just simply never work. Also, there's an interesting one here. If you see this, such an error, so CS0649, and because it's never assigned to, and you will never assign to it in your code, you can just simply have a pragma, as far as I remember, pragma, disable, CS, or I think CS0649, I think, or something like that. And then you have in the bottom, pragma restore CS0649 or something like that. Oh, hang on a sec. Let me see. Pragma disable warning, and let me see the Microsoft documentation. What does it say? So yeah, there you go. Pragma warning disable. Pragma warning disable this, and I think you need just only the code, and then Pragma warning restore, and this, as far as I remember. Right now, they should disappear. Now you use them carefully, so you will not disable everything. I'm putting this here, so you will not have problems with Unity spitting at you stuff which you don't care about, because you know that you are assigning it through the editor. Okay. Now, private key code. If you have forward, back, right, and then private key code, and then you have left, and then private key code, and then you have fire, and then was there was a very interesting move I liked in Starlink Battle for Atlas. It's a game, space game, where I'm actually like running with a ship, and then when somebody's firing at me, I just press the evade button, and it will just simply flip somehow, and I evade all the bullets, which makes me feel like a badass. But you know, I haven't done anything but just a button. So I like to give this player to give the player the feel of like you have been a badass by making a better roll flip with an airplane or with a jet, space jet. So I'd like to give that. Now, here's the interesting part. Actually, I could I will just talk about this in a second. So let me let me introduce a very interesting concept here. If you remember the lesson, we talked about delegates and stuff like that, delegates and lambdas and these things. If you remember that lesson, right now I'm going to use it. So public event action. An action is a class that needs using system on forward key pressed or key down, or on forward, I could say. Yeah, okay, on forward. Sorry, key pressed. Let's say like this. Okay. I have this. Now on back, on left, on right, on left, on right, on fire, and then on evade. Okay, you have all those. Now, if somebody remembers, anybody worked with Windows Forms? Have you guys worked with Windows Forms? Anyone? Did everybody go to sleep? Hello? Okay. So we have some people worked with Windows Forms on PRT. Okay. So do you remember the button event click? So say on button click, when you click on a button, just some things happen. This is the stuff which if you go into the Windows Forms designer, you select a button, double click, and it will just simply generate the event handler for you, and you fill in the code. We write that stuff by our hand. This is what happens when you actually start making the button, like try to create the event, or the event has been created within the button description of the API, because your buttons are actually related to the Win32 API. It is somewhere deep there, and Windows through C#, Microsoft with C#, they expose to you these events so you can actually play with them. Right now, I don't need this. And whenever someone is pressing that button, please call that event. Right? And in fact, I don't need this anymore. So on back, key pressed. I could even make this, but yeah, no need. If input.getKey, whoever presses right, please make this on right key pressed. And if input.getKey left, on left key pressed. And if input.getKey higher, and there's going to be on fire key pressed. If input dot get key evade, on evade key pressed. Okay, so whoever handles the event, this event or this event or this event, please call that method when that happens. We good? Now, if I go right now to this Starship, I could create a new folder, and I'm going to call this player scripts. Okay? And right now I'm going to put here, not folder, but a new script or a new C# class. This is going to be the player controller. Now, if once it's done, I open this. We have the player controller right here. And right now, I say on void awake, I can start handling these events here. I don't need the update even anymore, because whenever I press a button, that update, that method is going to be handled here. It's going to be called right here on the update. So we are good. Now, we need to include first the input. We need to have a reference to the input management. So what I'm going to do here is I'm going to have a private input management. And I'm going to call this serialized field. Now, the reason why I'm putting this private is that I don't want anybody to come from somewhere else out of the blue and just simply change my input management to something else or hack my code for any kind of reason. The Preil controller should have a reference to the input management, and nobody should touch what's happening inside the input management, nor anybody should modify anything in there. Even though I protected my input management with privates and stuff, but I don't want somebody to, modify these events from the outside or hook up other events from the outside, okay? Well, at least this is my design decision. So if I go here, I look at the Starship, I drag the player controller onto it, and right now I have the input management. Now, of course, I could go ahead to be nice and neat in my work. I could put here a header, and I'm going to say this is input management. And right now, after it, we can have header, we can have ship configurations, and right now we can have a private speed, private float, speed. So we have the speed of the ship. This, by the way, Control Enter to make a space be like above the thing and above the variable, and just put a new line. So if you are here, Control Enter, and you just simply go ahead and create a line. And right here, I'm going to have a range in order not to break the game. So I'm going to have a range from, let's say, 5. So I can have some visuals to, let's say, 20. And this is going to be the maximum speed which my ship can have, not to break the game or anything. And yeah, I think this is pretty much it. Let's see how these things look like. Oh, actually, also, for the kick of it, this controls the speed of the ship. Now, oh, I forgot. Serialized fields. So right now, we have the input management, which is going to be attached. I'm going to attach it from here, like so. And then you have the speed, where you can actually modify from 0 to 20, from 5, sorry, to 20, okay? So I'm going to leave it at 10 for now as a good manager. I'll leave it at 10. So I'm leaving it there. All right. Now, how do we handle the events? So let me see. Input management is there. So I can actually only awake or void start for that matter. It doesn't matter which one. I can even put it as a start and nobody will complain. I'm going to say input management dot. You see the events? So on forward key press plus equals, and how we add on the delegate stack. Now delegates are also be able to stack above each other because, by the way, if you haven't tried that yet in Windows Forms, you could actually attach several events to one function pointer, to one delegate. So you can actually handle. So you can have multiple events addressing the same method. Okay. So imagine that you have. So for example, imagine that you press a button. In Windows Forms, you could, for example, hit the save button by pressing the save button, right? Like by going to the file and then save, or you hit Control S. Now both of these functions address one method, which is save, right? You can have the two same and then you can have another method, right? Or actually, you can have even the on forward key pressed. You can have you can have, practically speaking, another method, or doing the same thing. Or you can even like on forward and back, and it will just simply, go ahead and point to the same method. Okay. So this is how you actually do save with two shortcut keys. Execute one single function with the same shortcut key, right? With two different shortcut keys. So we have Control S for saving, which will call the same method, this save method, and then you have the file and save, and then we'll call the save method again. So this is how you can do that, and they stack. So you could actually, if you register right now these two buttons at the same time, you can actually do this. By the way, it is legal, but it means that you're gonna. If you hit up, it's like you hit up twice. So you have to be really careful when you are writing this by your hand. Okay? So on back key press, plus also on back key pressed, so input management dot on forward, on left key pressed, so plus equals and tap. And then input management dot on forward, back, left, right, and then input management dot forward, back, left, right, fire, key pressed, and then input management dot on evade, key pressed. So I think I've handled all of them. Now, keep in mind, if you look right now at my code, it's much cleaner. I collapsed this code, I don't need it. Now, you see, all my inputs, I'm going to handle them in methods, and I can just simply keep my code as clean as possible without polluting my update method for this. The cool thing about this little guy, I can grab it and I use it in another project, and it will work just fine. Now, here's a very important thing which I forgot. Serialized field. Actually, serialized field. Okay. Now, if you look at my input management here, I can say, oh, enums convert to drop downs, by the way. Inputs are just simply text, but enums usually they turn into a drop downs, and you can put your own. So down, hang on, right is going to be right arrow, left is going to be the left arrow, fire, I'm going to use the infamous space, and probably evade is going to be the left control. So I'm just going to scroll down, left parent. Oh, left control. Okay, so right now we have that. Also, okay, we have that, we have that, we have that. Yeah, so let me just right now put in the debug.log. So debug.log, not log error, but log. And right now I'm just gonna, because log error will just show you an error instead of just normal log. And this is depending on what you would like to communicate with your people, with your team. This is gonna be evade button pressed. And for the good measure, I'll just simply put the forward as well, just in case. And I'll erase these exceptions because they are gonna throw the exceptions in the Unity log. It's kind of ugly and I haven't handled them yet. And this is gonna be forward. Maybe while I'm at it then, back and left. Not worthy of pull request, but right. Ooh. I can't, okay. Some time ago, see, Visual Studio actually allowed to swap letters by pressing Control T. I don't know where did this thing go away though. This is gonna be fire. Evade button. Okay, we are good. So if I actually go ahead in Unity, okay, probably I need to add the suppressing thingies so it doesn't bother me. I'm well aware that this is actually being assigned from my editor. So I'm well aware this is assigned from my editor, hence go away. Thank you. Now we have our input management. We have set it up. We have set up the keyboard shortcut keys. We go to the starship. We have the input management. We have the speed and the ship configuration stuff. So I could go ahead. The ship will not move, of course, up. So this is the forward button press, right, left, down, and then we have space, fire, control, evade, and we are good to go. So we have that done. We have our inputs management has been handled. Now there are a couple of things which I could actually add, but probably not today. I will stop actually right here because the next time we are going to add interactivity. We're gonna fire bullets. We're gonna probably have enemy ships coming at us, and we're gonna see how we're gonna, do this kind of thing. Oh, by the way, also this is what the thing which Windows Forms does for you by hand. So I'm actually gonna on destroy. I think, was it on destroy? What was the last one? I think it was on destroy. Was it? Hang on. Yeah, on destroy. So on destroy, once this is being destroyed, please unsubscribe from all these events. Why? Because if you destroy your ship, you shouldn't be able to fire bullets, you shouldn't be able to maneuver, you shouldn't be able to do anything. Huge bug you could introduce into your game, and if somebody discovered that, they will just simply try to carry on and do crazy stuff. So, or kill the boss, let's say, if they have like the latest moment, like the last bit of health, as they usually do. If somebody is playing any of these interesting arcade games, or Dark Souls for that matter, they know the agony of like, that small little health is left, and just you die. So once you die, that's it. Nobody can touch the keyboard. You cannot do anything anymore. All right. This, by the way, Windows Form does this for you. Probably need to dig a little bit deep into your code to see this. So yeah. I think this is pretty much it. So I'm gonna just simply beautify the code a little bit here. This code is gonna be uploaded, by the way, and we're gonna keep adding to it until like every time I add to it, I'll just re-upload it and re-upload these versions until you guys get the whole progress. Like you see the progress from start to finish. To be honest with you, I use this code in production. Sometimes this kind of handling, I use them in production because it's much cleaner that way. And I separated the concerns. The input management concern is to handle the inputs of the user. The player controller concern is to move the player. So right now I just simply separated those two, and I have much cleaner code and easier code to maintain. All right. This can be used in C#. This is used in C#, by the way. This is not Unity stuff. This is actually compiler flags. You can use them anywhere. It's not only Unity stuff, by the way. Are there any questions? Questions, answers. Do you guys, was it too fast or something like that? Do you have anything? Do you need anything to be explained, or I don't know what. So you guys shoot. Was it clear? I saw already 2 people. Oh, even more people are just leaving already. So I think if there are no questions, if you are one of those shy people, feel free to shoot me an email and I shall help you out. Okay, you guys take care of yourselves and your loved ones in these difficult times, and I hope to see you soon then. Okay.